Teleportation. The word itself sparks images of instantaneous travel, vanishing from one point and reappearing in another. It's a concept that has captivated the human imagination for centuries, fueled by our desire to overcome the limitations of time and space. Imagine stepping into a booth, inputting your destination, and in a flash, arriving at your desired location. No more traffic jams, no more long-haul flights, just instant travel to anywhere in the world, or even beyond. Teleportation, in its purest form, involves dematerializing at one location and perfectly reconstructing oneself at another, a feat that seems more aligned with science fiction than scientific reality. Yet the allure of teleportation persists, driving scientific inquiry and pushing the boundaries of our understanding of the universe. While we may be far from beaming ourselves across continents, the journey toward understanding teleportation has already begun, taking us deep into the realm of quantum physics, a world where the seemingly impossible can become possible. The concept of teleportation has been a staple of science fiction for over a century. From the earliest pulp magazines to blockbuster films, teleportation has served as a plot device, a technological marvel, and a source of endless fascination. In literature, H.G. Wells' The Invisible Man explored the idea of matter transmission, albeit in a more sinister context. However, it was the advent of television and cinema that truly brought teleportation into the mainstream. Star Trek, with its iconic transporter room, ingrained the image of teleportation in the public consciousness. The ability to beam characters to different planets instantaneously became synonymous with futuristic travel and advanced technology. These fictional depictions, while often fantastical, have served an important purpose. They have sparked our imagination and fueled our desire to explore the possibilities of teleportation. They have challenged us to question the limits of science and to envision a future where the impossible might just be within reach. To understand the scientific feasibility of teleportation, we must first venture into the strange and counterintuitive world of quantum physics. This branch of physics governs the behavior of matter at the atomic and subatomic levels, where the rules of classical physics no longer apply. In the quantum realm, particles can exist in multiple states simultaneously, a phenomenon known as superposition, and can be inextricably linked even across vast distances through a phenomenon called entanglement. These quantum phenomena, once considered mere theoretical curiosities, have emerged as potential stepping stones towards realizing teleportation. Quantum superposition, for instance, suggests the possibility of matter existing in two places at once, while entanglement hints at the instantaneous transfer of information between particles, regardless of distance. While these concepts may seem abstract, they form the foundation for understanding the scientific principles that could one day make teleportation a reality. At the heart of teleportation lies the mind-boggling concept of quantum entanglement, a phenomenon that even Einstein famously dubbed spooky action at a distance. Entanglement describes a special connection between two particles, where the state of one particle instantly influences the state of the other. Imagine two coins flipped simultaneously, one always landing on heads and the other always landing on tails. This instantaneous connection has profound implications for teleportation. Entanglement provides a crucial mechanism for transferring the quantum state of a particle, a fundamental step towards teleportation. While the teleportation of humans remains a distant prospect, scientists have made significant progress in teleporting quantum information. In 1993, an international team of physicists proposed a theoretical framework for quantum teleportation, and just a few years later, in 1997, the first experimental demonstration of quantum teleportation was achieved. This groundbreaking experiment involved teleporting the quantum state of a photon, a particle of light, across a distance of about 1 meter. While teleporting a single photon may seem a far cry from teleporting a human, this experiment marked a crucial milestone, proving that the teleportation of quantum information was indeed possible. Since then, scientists have successfully teleported the quantum states of photons over increasingly longer distances, even achieving teleportation through fiber optic cables and into space. These experiments, while still in their early stages, provide tangible evidence that teleportation, at least at the quantum level, is not just science fiction. Despite promising advancements, teleporting large-scale objects, especially humans, faces significant challenges. The complexity of living organisms is a primary hurdle. Humans are composed of trillions of atoms, each with a unique quantum state. Scanning, transferring, and reconstructing these atoms is beyond our current capabilities. Measuring a quantum state alters it, known as the observer effect. This poses a significant challenge for teleportation, potentially leading to errors. These challenges highlight the immense technological hurdles we must overcome. The potential realization of teleportation raises a plethora of ethical and philosophical questions that extend far beyond the realm of science. Who would have access to this technology? What would be the environmental impact of instantaneous travel? And perhaps most importantly, what would it mean to be human in a world where teleportation is commonplace? The accessibility of teleportation would undoubtedly be a major concern. Would it be a luxury reserved for the wealthy, or a public utility available to all? The equitable distribution of such a transformative technology would be crucial to prevent further social and economic disparities. Furthermore, the environmental impact of teleportation cannot be overlooked. If teleportation were to become a widely adopted mode of transportation, it could potentially alleviate some of the environmental problems associated with traditional travel, such as carbon emissions. However, it could also have unforeseen consequences on ecosystems and wildlife, as the instantaneous movement of matter across geographical boundaries could disrupt delicate ecological balances. Teleportation poses profound questions about personal identity. Would the person who arrives be the same as the one who entered? Some argue it's a form of suicide as the original body is destroyed. Others say if memories and consciousness are retained, it's the same person. This debate challenges our understanding of selfhood and continuity. The advent of teleportation would not only challenge our understanding of personal identity, but also reshape our relationship with space and time. The ability to travel instantaneously would render distance meaningless, collapsing the barriers between locations and potentially altering our perception of the world around us. Imagine a world where commuting to work involves stepping into a teleportation pod and arriving at the office in an instant, or where visiting family and friends across the globe is as simple as making a phone call. Such a world would fundamentally alter our understanding of proximity and distance, potentially leading to a more interconnected and globalized society. However, this interconnectedness could also come at a cost. The ease of travel could lead to a homogenization of cultures as the barriers between different societies and traditions become blurred. The unique character of individual communities could be lost as the world shrinks to the size of a teleportation pod. So, is teleportation merely a science fiction fantasy, or could it one day become a reality? The answer, like most things in science, is complex and uncertain. While the teleportation of humans remains firmly in the realm of speculation, the rapid pace of scientific advancement, particularly in the field of quantum physics, suggests that we may be closer to understanding the principles of teleportation than we ever thought possible. The challenges ahead are undoubtedly immense, requiring breakthroughs in our understanding of quantum mechanics, the development of technologies far beyond our current capabilities, and careful consideration of the ethical and philosophical implications of such a transformative technology. Yet the human spirit of exploration and innovation knows no bounds. Just as we have achieved what was once considered impossible, from splitting the atom to landing on the moon, the dream of teleportation may one day transition from the realm of science fiction to the annals of scientific achievement. The quest to understand and harness the power of teleportation is a journey into the unknown, a testament to our insatiable curiosity and our desire to push the boundaries of human ingenuity. While the ultimate realization of teleportation may lie generations in the future, the pursuit of this seemingly impossible dream is already yielding valuable insights into the fundamental nature of the universe and our place within it. As we delve deeper into the mysteries of quantum mechanics and explore the potential of entanglement, we are not only uncovering the secrets of the cosmos, but also challenging our own preconceived notions of what is possible. The future of teleportation remains uncertain, but one thing is clear: the journey itself is just as important as the destination. Whether teleportation eventually becomes a reality or remains a tantalizing dream, the exploration of this concept will undoubtedly continue to inspire generations to come, reminding us that the universe is full of wonders yet to be discovered.